talking. Okay, so here we go. Kiddos, how do I make, I need an n. I need odd numbers. Have you guys figured it out yet? How do I make odd numbers?
-1 to...
Okay, I do need -1. I'm starting with a positive, and I start with n equals 0, right? So I can make that n. N is 0, positive. N is 1, negative. N is 2, positive. N is 3, negative. Good. I need to plug in 0 and get out 1. Plug in 2 and get out 3. Plug in 3 and get out 5. So I'm going to have x to the, plug in 0 and get 1, plus 1. So I have to plug in 0.
Oh, okay.
So plug in 0, 0 plus 1, 1. And then plug in 1, 2 plus 1, 3. And then plug in 2, 4 plus 1, 5. Got it. All over, I need odds factorial, so 2n plus 1. Does that work? Plug in 0, 1 factorial, 1. Plug in 2. No. Oh, plug in 1, 3 factorial. Plug in 2, 5 factorial. Got it. What would be the nth term for this one? What's different? -1 still.
N plus 1.
The power.
No, N.
I think it's still it's because 0.
Oh, yeah, it's N.
Yeah, it's n. And then x to the, wait a minute, well, what is x to the? Maybe we should do a little simplifying. So we have x squared minus x to the power to a power we multiply, right?
14. What's the top? 6 plus 4 plus 4 plus 4.
Well, couldn't I just do? Does that still work? Because I can still have to the 1 to the 3 to the 5 to the 7, just what's different, I have x squared. So it's going to be the exact same thing, just with an x squared plugged in, which makes sense because it just has an x squared plugged in, right guys? Okay, we finished. Example number 8.
This one was in the other 9-7, I think.
How do you do it? Because now we have it memorized. 9-7, we kind of had to find it. That was the difference.
Can I see example 7 really quick? Can I cheat and go back to 9-7?
No, we don't need to cheat and go out to 9-7. Oh, you already have it? Okay. X cosine x. Hold on. What do we start with? What do we have memorized in Maclaurin series, or we should get memorized in Maclaurin series for? Cosine. Cosine has what kind of symmetry? Even or odd? Odd symmetry. So it has the odd powers. It's just a way of remembering. So cosine is going to have 1, right? 1 minus x squared over 2 factorial, focus, plus x to the 4th over 4 factorial, minus x to the 6th over 6 factorial. No, not over. Yes, over. Yes, over. Plus. And the general term. Aw, stink. Well, hold on. We have evens, right? So we have -1 to the n still, because positive, negative, positive, negative. I have x to the... Does that make sense? When n is 0, it's 0. To the 0, which is just 1, right? And then when it's 1, it's 2. When it's 2, it's 4. When it's 3, it's 6. Got it. All over. Okay. How do I do x cosine x? Well, guys, algebra. If I get to multiply cosine by x, what else do I get to multiply by x? Algebra says if you do it on one side, do it on the other. So if cosine is this, then okay, fine. If you multiply it by x, okay, fine. Multiply by x. X minus x cubed over 3 factorial plus x to the 5th over 4 factorial, not 5.
Why is the second one 3 factorial?
It's not. It's not supposed to be. 2 factorial, 4 factorial. Minus, oh goodness gracious, it's a rough one. Minus x to the 7th all over 6 factorial. What's different? Still have -1 to the n. But now, it's 2n plus 1. But I still have 2n factorial. Right? You guys agree? Because I can multiply everything by x. So when I multiply by x on this side, I have to multiply by x on this side. But a polynomial, how do I multiply by a polynomial? I go times u, n 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 times u, right? Etc., etc., etc. Okay. Example 9. Ooh. Ooh. How many of you guys want to actually find the Maclaurin for that?
No.
No.
So is there something else that we can do?
No.
Is
Plug in. Plug in. What's e to the x equal as a Maclaurin? It's a special one. We're supposed to memorize it. 1 plus. Is it this one? Double check. Where should you be looking right now? In your notes at the special ones we're supposed to memorize.
That's it.
The best one.
Why is it the best one?
I don't know. No alternating. No skipping. Just plugging in. Because e to the 0 is 1 and it's always going to be e to the 0, e to the 0, e to the 0.
Is that cosine?
Wait, cosine? No. Cosine?
No.
Cosine goes 1 squared fourth.
No, I mean e to the x plus.
Guys, how do we do e to the negative x? I'm getting my pieces all worked out.
It's like the
I plug in negative x, right? So it'll be 1 plus negative x, right?
Who's the first one still on?
Well, there's nothing to
Oh,
plug
sorry.
in,
Yeah.
right?
Oh, I understand.
So I can do 1 plus negative minus x. Plug in negative. Anything change? No. X squared over 2 factorial. Negative squared is still positive. Plug into cubed. What changes? Negative, right? So how do I actually solve? I don't need to find first derivative, second derivative, third derivative, fourth derivative. I can take each of these pieces and say, okay, e to the x plus e to the negative x all over 2 is going to equal 1/2 times, right? Over 2, messy. 1/2, bring out e to the x. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Yep. You guys see it already? Minus 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial.
I think it's plus.
Oh, thank you, formula. My bad. Plus. So what's going to cancel? Everything negative. Which will end up being, Layla, everything odd. Oh, odds are out, evens are in. Odds. That was so last year. Just kidding. 1/2 times, what's left? 1 plus, wait, not 1. What's 1?
He's gonna double.
2. Because 1 and 1, right? And then x squared over 2, x squared over 2, 2x squared over 2. And then, what's going to be x to the 4th? 2x to the 4th over 4. Wait a minute. Can I pull all those 2's out?
Yeah.
And if I pull all those 2's out, 2 and 1/2 cancel, so I have 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial plus, did they say general term? General term. X to the 2n over that looks good, right?
So my guessing is right.
Was your guessing just pure guessing? E to the x plus e to the negative x? Of course. Or was it thinking about each of them and plugging? No, I don't think it was just guessing. I think it was mathematically problem solving quickly. Okay. It's not magical, it's math. Okay, so. Zoom.
Oh,
2 more, then we're done. Actually, 1 more and we're done, right?
I don't have any more.
Oh, wait, how about number 11?
Yeah, I don't have
Yeah, mine didn't do that.
You don't have 11 what though?
any. No, just 9.
No,
Why didn't they copy it?
that's okay. We just.
Can we just do it quickly together? It'll
Oh,
be easier
yeah.
so you guys can be done.
It's in the homework. I mean.
Oh, it is in the homework. It's totally in the homework. You guys are right. This is homework help.
Yay.
This is homework help. These are in the worksheet. I think.
Yeah, there.
ones you didn't want to do yesterday? Alright, I'll help a little bit.
Yay.
What should you have done?
Take derivatives. You have to eat derivatives.
Yeah, I choose a derivative.
Yeah.
Because I don't know how to do that.
Well, because there's nothing that matches, right, in our special series?
Can there be?
Well, you could look, but I don't think there's anything that works. We have 1 over 1 minus x. So that's it. So now if we take first derivative, second derivative, I'm going to do things quick, kiddos, but if you took them all. I'm keeping general because this will be a little bit harder. How many terms? 3 terms, which means I think, 4 terms, which means only 3 derivatives, right?
Yeah.
There's no derivative first, second, third. Okay, so I have I already did this, so I'm just doing it fast because I know you guys can take derivatives.
Or can.
Hopefully. Okay. Those are derivatives. I know how to find Taylor series, right? First 4, I guess I could do dot, dot, dot. Then that says equals, right? What am I plugging in? 0? So f of 0 would be square root of 1 plus 0, which is 1, right?
1.
Plus f prime of 0, plug in 0,
1
1/2,
half.
times x to the 1, right? X minus 0 to the 1. Plus, ooh, but it's going to be a minus, right? Plug in 0, any power of 1 is 1, negative 1/4. Times x squared over 2 factorial, right? Plus 3/8 times x cubed over, we should simplify though. What do we have? 1 plus minus 4 times 2 factorial. Is that anything good? Not really.
1/8.
Yeah. 8 times 3 times 2 times 1, 8 times 6, 48.
Oh, sorry.
They didn't say general term, which is nice, so we could just stop. That's enough. So yeah, just to remind you, even though there are some shortcuts, some don't, and you have to take first derivative, second derivative, third derivative, in order to be able to plug in. But kiddos, once you find that, how can you do B? We had to do A the long way, but what does B?
Just,
I'm using the same thing, except instead of doing f of x, what am I doing? Right? Because instead of x, I'm plugging in x cubed. So I can take this exact same thing and I can say, okay. X cubed squared. X cubed cubed. See what I mean? So what they're saying is you don't, it's not only with the e to the x, sine of x, cosine of x, 1 over 1 minus x. It's not just those ones you can do this with. You can find your own Taylor series and then apply it for something else with a similar pattern and not have to make as many messy derivatives. Who would be easier to take derivatives of, A or B?
A.
Yeah. So take his derivatives and plug in x cubed. Okay. What would you guys do on number 11?
I would. Just kidding.
Would you have to derive it one? Or no, they gave you the actual derivative.
You just use the one you have.
Mm-hmm. What's the one you have?
Each derivative.
X squared minus x to the 6 over 3 factorial.
That
Plus
one.
x to the 10 over 5 factorial.
Oh, that's what you had in the beginning. You didn't take the integral yet?
Yeah.
Okay. So you have
do
x squared.
want the integral? I have the integral.
We'll get there.
I plugged it into my calculator.
This is after you plug in an earlier problem. How many terms? Didn't say?
No. It just says use your answer from 7. And 7 only said 4.
Okay. How do I take integral? From 0 to 1? Take integral of one side, take integral of the other side, right? And the integral of x squared is going to be x cubed over 3 minus x to the 7th over
7 times 2.
that works for me. X to the 11th over 11 times 5 factorial, x to the 15th over 15 times 7 factorial. Now it said use it to approximate to correct to 3 decimal places. Wait a minute, how do I know? Hold on. Is there something to do with when I'm approximating a function? No, let's not say it that way. If I'm solving, question, does sine of x squared equal part of this or all of this?
No.
Does sine of x squared equal all of it plus dot 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 or only part of it?
Only part of it, but it's still one, right? Or no?
That R.
All like the series.
Well, I was thinking just sine of x squared. Sine of x squared equals, it must be all of it, right? It must be the,
And
right?
Yeah.
series.
The infinite series. Wait a minute. If they're asking me to approximate an infinite series using a certain number of terms, what's the only type of infinite series that I can approximate or I can figure out the sum of? Geometric, that's not this. Telescoping, not matching. Alternating series. Is this alternating?
Yes. Yeah.
Yes. Right? If I was to make the nth term for this, if I needed to, I could make the nth term by saying -1 to the n, right? X to the 2, 6, 10, 14.
4n plus 2 x to
4n plus 2, because it's 4 plus 2, 8 plus 2, 16.
we just need that.
12 plus 2. Okay. So then x all over 2n plus 1 factorial. Does that work? Anyway, whatever. I have an alternating series. Hold on. I can approximate an alternating series using an nth partial sum, and the error is going to be less than the next term, right?
Yes.
Okay, so if I was to approximate correct to 3 decimal places, question, what have I not really done yet that I should do? All of this is just the antiderivative, right? So I would still need to go from 0 to 1, true? Now, when I plug in 1, what do I get? 1/3 minus 1 over 7 times 3 factorial plus 1 over 11 times 5 factorial minus 1 over... When I plug in 1, okay, when I plug in 0, remember f of b minus f of a, plug in 0, 0, 0, 0, 0, 0, okay, forget it, right? So this is, hold on, plus dot dot dot. That's the answer, but it says approximate to within 3 decimal places. Then hold on, I need my error to be less than 3 decimal places. Now, we could set up all this mess, or we could do it kind of a cheater way. Here's a cheater way. We could actually set up the nth term. Don't we have the nth term, guys?
Yeah.
Correct to 3 decimal places. I could set up my nth term and say 1 to the 4n plus 2 all over 2n plus 1 factorial, and I could try to solve. Or I could say, hey, he's 0.333. He's 0.3095. I'm finding partial sums. I did the first and the second, I did the first, the second, and the third. This is off to the side. 0.3102. First 4, 0.31028. Wait a minute. Where do I stop? Where do I stop
When to,
for 3 decimal places? Yeah. .310. Wait, and you didn't have to know the integral of sine of x squared, and you didn't have to plug in numbers that we don't know trig functions for? Ooh, usefulness of Taylor series and Maclaurin series. Solving for sines and cosines and integrals and derivatives when we don't even know or have a calculator to plug in. Well, okay, I cheated and plugged in a calculator, but that's okay.
Crazy.
All right, we are going on to section 9-9.
Do we have a sheet of this?
Yep. Here we
So
go.
many. Okay. Let's do it. Go with it.
Oh, this is the wrong one. Hold on.
47 is the magic number, Misty.
Wait, 47 what?
School day.
left.
You should go see Cinderella.
Is it already out?
Yeah, it's out on Friday.
We should go with
The story is the obvious one?
We can
It's
learn
not true.
some
Okay.
calculus.
If they did change Cinderella, it'd be like all the other changings of Cinderella. Worksheet, take one, pass around.
Thank
No.
you.
So many worksheets.
Put your name on it.
I think I lost the worksheet and
For 9-8?
the one that I got it after school.
So you need another one.
Wait. Yeah, one more.
Coming after school today. And then, you're right there. You got it.
Sicily.
And I have 2 seats.
Layla only has one.
You know, Mr. Weitzel made a joke about my leg today too.
What did he
I wasn't
say?
making a joke.
No, what did he say? Wait, what did he say?
It
I was
was like
thinking.
something
Ethan, you
about
wanna take
like
one from Angie
somebody
too?
going,
You
like
give her
he's
tomorrow?
like, oh, for all the disabled people.
No.
I was like, excuse me?
Wait, what
I
did you say?
was compared. I was
For
the.
all the
I
disabled
was
people.
the metaphorical Mona Lisa.
It's rough. It's a rough crowd. You guys putting names on it or else you're gonna lose it. You putting names on it or else
Melissa's
you're
name
gonna
on
lose
it
it. So I just
No.
shocked myself.
So I can get the grade
No.
Monday. So that she can get a back grade.
Excuse you.
Alright, you guys got it?
Yes.
55.
Guys, what power series have we seen so far? McLaren. And McLaren ones are Taylor. McLaren or Taylor, they're centered at 0, right? McLaren and Taylor. Have we really seen any other ones?
No.
Not really. Well, hold on. Power x minus, no, not really. But section 9.9 says power series that are geometric series. Power series that are geometric series. So let's think back to a geometric series real quick.
Okay.
What if I was to take one of the special McLarens? Guys, what's this one equal? It's not e to the x, it's not sine of x, it's not cosine of x, but it is special.
1 plus
1
x
plus x
plus
Mhm.
plus squared plus x cubed plus x to the 4 plus x to the 5th plus x to the 6th.
Okay, we're good. Layla's having too much fun. Plus x to the n plus dot dot dot, right? If we were to do the nth term, I suppose maybe we should. It seems like they think the general term is kind of important, and it is, because that lets us write it as a series. Oh. Question. Wait a minute. Is this a geometric series?
Yes.
Why?
Because it just multiplies by x.
Because I have a common ratio, and that common ratio every single time is adding. I have times r. Wait a minute, not just r, it's times, what'd you say, Melissa?
X.
It's times x, right? So r times x. How do you do times x? Times x? Anyway, okay.
Dot
R
x.
equals x. True.
Yes.
R equals x. So I could say geometric series. This is my a sub 1 is equal to 1. My r is equal to x. So question, does this converge?
No.
If it's a geometric series, we should know when it converges.
But we don't.
X is unknown. X is unknown, but does that mean that we can't say anything about its convergence?
Well, it's
Since it's geometric, what can I say?
converges when r is equal to negative 1 and 1.
So hence when x is in between 1 and negative 1, right? And if x is in between 1 and negative 1, this converges, and not only it converges, but it converges to what? Guys, if a geometric series converges, what can I write as its partial sum? No, his entire sum, his infinite sum. What does the sum of an infinite geometric series, if it converges, equal?
1 over 1 minus x.
Which, applied to this example, would be 1 over 1 minus x. Right? So even though we look at this and say, hey, it's a rational, oh wait, look back up here. Did you guys already write it? A rational function, aka like an f of x over g of x. Can I take a rational function and write it as a geometric series? Or can I take a geometric series and write it as a rational function?
Yeah.
Yes.
Ooh, that's exciting. Okay. Let's keep going. Example 1, notes. Quick review. We've been there, we've done that. It's been really recently, right? Quick review of geometric series. Suppose I told you, I can't even, stole you? I don't know. Suppose I told you to start with a sub 1 equals 2 and to let r equals 3. A sub 1 equals 2 and r equals 3. What geometric series would you write? What would be the sum in each case? All right, let's start off with the first one. So if a sub 1 equals 2 and r equals 3, kiddos, what would my series be? Well, I would have 2 plus 6 plus 18 plus 54 plus question. What's my sum?
1 over 2.
Wait, no. Look at it. 2 plus 6 plus 18 plus 54, because I start with 2 and I say times 3 times 3 times 3. Right? R is 3. Does that converge or diverge? Diverges. If it diverges, is there a sum? No. I know, trick question. Diverges, therefore no sum, right? Infinite sum. None. Infinite. Doesn't that make sense? 2 plus 6 plus 18 plus 54. Yeah, nope. All right, what if a equals 2 and r equals negative 3? 2 minus 6 plus 18 minus 54. Is this going well? Nope. But geometric series, r is equal to negative 3 diverges. I don't need to find a sum. There is none. Right? No sum. How about the bottom one? 1. Converges sometimes. Converges sometimes. Right? So we've just seen geometric series can actually be rational functions. They just have certain intervals of convergence. Does that make sense? So geometric series can be rational functions, but with restrictions, usually, right? Okay, let's keep going. So, what if they gave me the following? Find the power series centered at c equals 0 by Taylor's rule, A, manipulating a geometric series, B, and doing long division. Wait, what? And doing long division. Find the interval of convergence without using the ratio test and verify by graphing each. Wait, what? Well, hold on. Taylor's rule. Well, hold on. Using Taylor's series. But it's at c equals 0, so therefore I can think Taylor's rule, I can think, hey, Maclaurin, right? So A just means, hopefully you're memorizing it, right? We don't want to find f prime, f double prime, f triple prime, so therefore, guys, you know this one. What is it? We just said it.
It's
1 plus x.
Right? And we can say plus x to the n if we did our general term. Keeps going, right? If we were to do the interval of convergence, we could go ahead and do, if we were solving, x to the n plus 1 over x to the n, because our nth term, right? So I can use only series, series and only series, or I can use seeing it as a geometric series. So I could just use the ratio test. Which is how we did all of our Taylor-Maclaurins, right? Or I could see it as when absolute value of r is less than 1, and since r is equal to x, I can say when x is equal to less than 1. So I can think about it as a Taylor series. I can think about it using the geometric series test, basically, right? Of when geometric series converge. Or, wait, long division? Huh? What would you have to put in the long division? What goes in the box? This is contrary to anything that you would think. What goes inside? Yeah, it has to. It's on top. Wait a minute.
Contrary.
Wait, how do... Well, because usually, we only do this when there's a higher power on top? Hold on, what happens when I divide? 1 goes into 1 how many times? 1! So I multiply 1 minus x. And I get x. How many times does 1 go into x? X. X times 1. X minus x times x. X squared. X squared. 1 goes into x squared. X squared times. X squared minus x cubed. Ethan's mind just got blown. And I get x cubed. Whoa!
What just happened? My world has been turned upside down.
Interval of convergence. Wow. How would you know interval of convergence? Interval of convergence. I don't think there's any way to really tell by the long division. When they said not using ratio test, they meant geometric series. We could do geometric series and not actually have to do ratio. So we can see it just as a Taylor polynomial and say, it's okay, not too bad. It converges, got the interval of convergence. We would have to test technically the endpoints, but it doesn't end up equaling. Right, we'd have to test at, I don't want to model this badly, at x equals -1, x equals 1. Not going to work, not going to work. I didn't do it. No time. I already knew the answer. But long division works too. What happens if I want the power series for 1 over 1 plus x?
This is in the other homework too.
What can I do? And I want the interval of convergence.
You can
I start with the one I know.
you make it just everything the opposite side.
It's like the,
And I say, to be a plus, what do I need?
the phone numbers are the opposite.
Plug in a negative x instead of a positive x. Does that make sense?
Yeah.
I can do 1 minus a negative x, right? And then I can say, okay, plug in negative x. That'll be minus x, negative x. That'll be plus x squared, negative x, minus x cubed. Right?
Yes.
And the general term. Minus 1, right? Minus 1. This one would be interval of convergence. What would I have to do?
So 2n minus 1.
I could say r equals negative x. And when will negative x be in between 1 and negative 1? Well, no problem. What happens?
It just switches.
Remember, divide by a negative, everything switches. Same thing.
Yes, that makes
I
sense.
remember that. That was so long ago.
Same thing. Nothing changes. What's going to change with this one? I could make it x times 1 over 1 minus negative x.
Oh, yeah.
Oh!
Yeah, I see.
Keep going. All right, cool kids. Start on homework. I think this worksheet. Oh, I didn't write it up there. Sorry. 9-9 is due on Friday. We're finishing tomorrow. Come ready. We're gonna start booking as soon as you guys get in here.